Hello students, welcome to our Rose project. Myself Mrs. Paul NR from SGM College, Karad. In last lecture, we started the topic ionic equilibria, and in today's lecture, we are going to see the ionization of acids and bases as well as Oswald's dilution law. First, we are going to see the ionization of acids and bases. Strong acids like HCl, HNO3, H2SO4, HI, HBr ionizes almost completely, and ionization represented by single arrow like this. HCl in aqueous solution dissociates as the H plus and Cl minus ions. Means all strong acids dissociates completely, and its dissociation is represented by the single arrow. In these acids, HCl, HNO3, HI, HBr are the monobasic acids, and hence this gives only H plus ions in the aqueous solution. But in case of H2SO4, it is a dibasic acid, and hence in aqueous solution it gives the 2 H plus ions. You have to remember strong acids and strong bases also. Strong bases like NaOH, KOH are also dissociates completely. NaOH dissociates as the Na plus and OH minus ions in aqueous solution. Here minus charge should be on this OH. Thus, the strong acids and bases dissociates almost completely. Once more, you have to remember the names of strong acids as well as strong bases. In case of bases, NaOH and KOH are strong bases. And in case of acids, HCl, HNO3, H2SO4, HI, HBr are the strong acids. Then weak acids like RCOOH, all carboxylic acids means acids containing the COOH group are the weak acids, as well as H2S is weak acid. In the family of HX, only HF is weak acid and all other HX are the strong acids. HCN is also weak acids. Thus, all RCOOH, H2S, HF, HCN are the weak acids, and weak bases are like NH4OH, ammonium hydroxide, FeOH thrice, ferric hydroxide, CuOH twice, copper hydroxides. This dissociates to small extent, and this dissociation represented by reversible arrow like this. NH4OH in aqueous solution dissociates as the NH4 plus and OH minus ions. This NH4OH gives the NH4 plus and OH minus ions in aqueous solution. Thus, these are the weak bases. Then next concept is the dissociation constant of weak acids and weak bases. Consider the weak acid HA in aqueous solution dissociates as the H plus and A minus ions. As this acid is weak, it dissociates to small extent, and hence its dissociation is represented by this reversible arrow. When we apply the law of mass action to this equation, the equilibrium constant K is equal to molar concentration of H plus ions into molar concentration of A minus ions divided by the molar concentration of HA. As this is a dissociation of acid, the equilibrium constant K here represented as the Ka. Here the symbol A for the acid. Ka means the dissociation constant of weak acid. Ka is dissociation constant of weak acid. Similarly, the dissociation constant of weak base BOH in water is represented as follows. BOH dissociates as the B plus and O minus ions in aqueous solution. As it is a weak base, it dissociates to small extent and hence there is a reversible reaction or reversible arrow. Then its dissociation constant is represented by the symbol Kb. B for here weak base. Kb is the dissociation constant of weak base. When you apply the law of mass action to this equation, Kb is equal to molar concentration of B plus into molar concentration of OH minus divided by the molar concentration of BOH. कोणत्याही रिव्हर्सिबल रिॲक्शनला आपण जेव्हा लॉ ऑफ मास ऍक्शन अप्लाय करतो तेव्हा त्याचा इक्विलिब्रियम कॉन्स्टंट घेताना काय करायचं, प्रॉडक्टच्या मोलर कॉन्सन्ट्रेशनचं मल्टिप्लिकेशन डिवायडेड बाय रिॲक्टंटचं मोलर कॉन्सन्ट्रेशन raised to their power equal to their coefficient. म्हणून तर या वीक बेसच्या रिॲक्शन मध्ये बी प्लस आणि OH मायनस हे प्रोडक्ट आहेत, म्हणून आपण काय घेतलं, मोलर कॉन्सन्ट्रेशन ऑफ बी प्लस इंटू मोलर कॉन्सन्ट्रेशन ऑफ OH मायनस. आता यांना कोएफिशियंट काहीच नाही, म्हणजे एकच बी प्लस आहे, इथं एकच OH मायनस आहे, पण रेज टू पॉवर इथं काय असणार आहे, 1 असणार आहे, 1 असणार आहे की जे आपण लिहिलेली नाही. डिवायडेड बाय काय घ्यायचं, मोलर कॉन्सन्ट्रेशन ऑफ रिॲक्टंट. हियर द BOH इज रिॲक्टंट. Therefore, Kb equal to molar concentration of B plus into molar concentration of OH minus upon molar concentration of BOH. Thus, the dissociation constant of a weak acid or weak base is defined as the equilibrium constant for dissociation equilibrium of weak acid or weak base respectively. That means the dissociation constant of weak acid or weak base means the equilibrium constant. Then we have to see the Oswald's dilution law. This law is applicable for dilute solution of weak electrolyte. This is also important. It is applicable only for the dilute solutions and for the weak electrolyte, that is for the weak acids or weak bases. Consider weak acid HA, which dissociates as, here HA dissociates as H plus and A minus ions in aqueous solution. Then Ka can be written as Ka is just we seen K is the dissociation constant of weak acid equal to molar concentration of H plus into molar concentration of A minus divided by the molar concentration of HA. आपल्याला जेव्हा क्वेश्चन विचारला जातो डिराइव्ह ओस्वाल्ड्स डायल्युशन लॉ फॉर वीक ऍसिड और वीक बेस, तेव्हा त्या क्वेश्चनच्या आन्सरची सुरुवात इथून करावी लागते, म्हणून हे पुन्हा आपण घेतलेलं आहे. आता आणखी देर आर सम इम्पॉर्टंट थिंग्स which are highlighted by this blue color. Consider 1 mole of acid HA present in phi dm cube. Dm cube means liter. Phi dm cube of solution, and alpha is the degree of dissociation. In your answer, 1 mole phi dm cube alpha must be or necessary. Then next, for writing this equation, you have to write this dissociation of HA at the right side. HA dissociates as the H plus and A minus. Then how many moles of HA present in solution? Initial moles. Initially, there is only 1 mole of HA is present in the solution. Hence, initial moles of HA is 1. Initially, there is no dissociation, and hence there is not formation of the H plus or A minus ions, and initial moles of H plus are 0, and initial moles of A minus are also 0. But when there is a dissociation and equilibrium is attained, then the moles at equilibrium. Moles remains at equilibrium. Out of 1 mole, alpha is the degree of dissociation, means alpha moles are dissociated. and hence moles of Ha remains at equilibrium are equal to 1 minus alpha. 1 मोल मधले अल्फाचं डिसोसिएशन झालं म्हणजे अल्फा मोलचं कन्व्हर्जन H प्लस आणि A मायनस मध्ये झालं म्हणून इक्विलिब्रियम स्टेजला HA चे किती मोल्स राहिले 1 मायनस अल्फा राहिले आणि H प्लस किती तयार झाले अल्फाचं डिसोसिएशन झालं होतं म्हणजे देर इज अ फॉर्मेशन ऑफ द अल्फा मोल्स ऑफ H as well as the alpha moles of A minus. Then concentration at equilibrium in moles per liter. You have to understand that concentration here taken is in moles per liter. That is moles divided by liter at equilibrium. Then how many moles at equilibrium of HA? HA are the 1 minus alpha moles. And how many liter solution? Solution is of phi liters. Hence, concentration at equilibrium of HA is here 1 minus alpha upon phi. As well as concentration of H plus here. Number of moles at equilibrium are alpha and solution is phi liters. Therefore, concentration at equilibrium is the alpha upon phi. Similarly, concentration of A minus is also alpha upon phi. Then at equilibrium, molar concentration, this again written in terms of like this square bracket. At equilibrium, molar concentration of HA is 1 minus alpha upon phi. Same written here but in the square bracket. Molar concentration of H plus equal to alpha upon phi and molar concentration of A minus is also equal to alpha upon phi. As we know the equation Ka equal to molar concentration of H plus into molar concentration of A minus upon molar concentration of He. Putting the values of these in this equation, Ka equal to molar concentration of H plus means alpha upon phi into molar concentration of A minus means alpha upon phi. Put these values from this equation. Then upon molar concentration of Ha means here 1 minus alpha upon phi and equal to alpha upon phi into alpha upon phi, that is the alpha square upon phi square divided by 1 minus alpha upon phi. This phi and 1 of this v is cancelled and there is alpha square upon phi into 1 minus alpha. Remember, K equal to alpha square upon phi into 1 minus alpha. Then the 1 minus alpha equal to C equal to 1 upon phi as 1 mole present in phi dm cube of solution. So how many moles? 1 mole. And what is how many amount of solution? Phi dm cube. And concentration is measured in moles per liter. C, that is molar concentration equal to moles 1 liter C phi. Therefore, C equal to 1 upon phi. Means C equal to 1 upon phi or 1 upon phi equal to C. Therefore, Ka equal to alpha square C upon 1 minus alpha. By this, here you see alpha square upon phi. 1 upon phi means C. Therefore, K equal to alpha square into C upon 1 minus alpha. K equal to alpha square C upon 1 minus alpha. But as alpha is very, very small because solution is dilute and hence 1 minus alpha is nearly equal to 1. Consider this sign nearly equal to. 1 minus alpha is nearly equal to 1. Therefore, Ka equal to alpha square C. If K equal to alpha square C, then alpha square equal to Ka upon C. And hence alpha equal to under root of Ka upon C. you have to remember this equation alpha equal to under root of Ka upon C, or as 1 upon C equal to phi or 1 upon V equal to C, alpha also equal to under root of Ka into phi. Means from this equation, the degree of dissociation of weak electrolyte is inversely proportional to square root of its concentration, or directly proportional to square root of the volume of the solution containing 1 mole of weak acid. See again this equation. Here this alpha is inversely proportional to square root of concentration, and here alpha is directly proportional to the square root of volume when 1 mole of acid is present in a solution. Similarly, if Oswald's law is applied for the weak base BOH, then derivation is same, but here BO only change that BOH dissociates as the B plus and OH minus, and final equation should be Kb equal to alpha square into C. In place of Ka, here write Kb, that is the dissociation constant of weak base, and alpha square equal to Kb upon C, and hence alpha equal to under root of Kb upon C, or alpha equal to under root of Kb into phi. Question may be asked that like that, derive the Oswald's dilution law for weak acid or Oswald's dilution law for weak base, or in general it can be asked as the derive the Oswald's dilution law for weak electrolyte. Next is the numericals based on this Oswald's dilution law. First numerical, see only first the question and not the answer. A weak monobasic acid, remember this Oswald's dilution law, this equation, that is Ka equal to alpha square C or Kb equal to alpha square C, these equations are applicable only for the monobasic acids or monoacidic bases. Then see this numerical, a weak monobasic acid is 0.05% 0.5% dissociated in 0.02 molar solution. Here percentage dissociation is given. From this percentage dissociation, that is percentage alpha, we have to calculate alpha by dividing this percentage by 100. या पर्सेंटेज डिसोसिएशनला 100 न डिवाइड केलं की आपल्याला काय मिळणार आहे, अल्फा. आपण लास्ट लेक्चर मध्ये बघितलेलं आहे. And air given 0.02 molar. See the unit, capital M, means this is a concentration given, concentration of solution. And we have to calculate dissociation constant of the acid. What is symbol of the dissociation constant of acid? That is Ka. Means we have to calculate Ka, and here given C and percentage dissociation. Then the dissociation constant of acid is given by formula used is Ka equal to alpha square C. Here alpha is calculated as percent dissociation divided by 100. How many percent? 0.05 divided by 100. 0.05 means 5 into 10 raised to minus 2 divided by 100 means into 10 raised to minus 2. That means which comes 5 into 10 raised to minus 4. This is the value of alpha. There, and C equal to 0.02 molar. 0.02 molar means 2 into 10 raised to minus 2 molar. And formula is K equal to alpha square C. Therefore, K equal to alpha 5 into 10 raised to minus 4 raised to 2, that is its square, into C 2 into 10 raised to minus 2. Then the square of 5 is the 25 and square of 10 raised to minus 4 is 10 raised to minus 8 into 2 into this 10 raised to minus 2. 25 into 2, that is the 50, and 10 raised to minus 8 and 10 raised to minus 2 means 10 raised to minus 10. The answer Ka is 50 into 10 raised to minus 10. This can be written as 5 into 10 raised to minus 9. 50चं जेव्हा आपण 5 करतो तेव्हा आपण एक घर काय करतो, लेफ्टला जातो. डेसिमल पॉइंट एक घर आपण लेफ्टला जातो. डेसिमल पॉइंट लेफ्टला जेव्हा आपण घेत असतो तेव्हा याची पॉझिटिव्ह पॉवर वाढवायची आणि डेसिमल पॉइंट आपण राईटला घेत असतो तेव्हा याची निगेटिव्ह पॉवर वाढवायची. द नेक्स्ट एक्झाम्पल, द डिसोसिएशन कॉन्स्टंट of NH4OH. Here NH4OH is a weak base and its dissociation constant value is 1.8 into 10 raised to minus 5. Means this is a value of Kb. Why? Because it is a weak base. Calculates its degree of dissociation. Calculate degree of dissociation means calculate alpha in 0.01 molar solution. 0.01 molar, that is C is given, means concentration is given, Kb is given, and we have to calculate alpha. Then what is the relation between the alpha, Kb and C? Alpha equal to under root of Kb into C. Value of Kb is the 1.8 into 10 raised to minus 5. C equal to 0.01, that means 1 into 10 raised to minus 2. Therefore, alpha equal to under root of 1.8 into 10 raised to minus 5 upon 1 into 10 raised to minus 2. That means alpha equal to under root of 1.8 into 10 raised to minus 3. हे 10 raised to minus 2 जेव्हा वरती येतात तेव्हा ते काय होतात, प्लस 2 होतात. त्यामुळे मायनस 5 प्लस 2 इथं किती आलं, 10 raised to minus 3. जेव्हा आपल्याला स्क्वेअर रूट काढायचं आहे तेव्हा ही जर पॉवर 10 ची निगेटिव्ह असेल, सॉरी ऑड असेल तर नियरेस्ट इव्हन नंबर मध्ये कन्व्हर्जन करायचं, म्हणजे आपल्याला त्याचा हाफ केलं स्क्वेअर रूट निघतो. ह्याचा आपण 10 raised to minus 4 केलं तर आपल्याला 1.8 चा किती होणार आहे, 18. डेसिमल पॉइंट एक घर 1 डिजिट कुठे जायचं, राईटला जायचं, म्हणजे याची एक निगेटिव्ह पॉवर वाढणार आहे. देअरफॉर अल्फा इक्वल टू काय आलं, 18 into 10 raised to minus 4. 10 raised to minus 4 चा स्क्वेअर रूट काढताना त्याची हाफ केली आणि किती आला, 10 raised to minus 2 आला. आता अंडर रूट ऑफ 18 किती आहे, 4.242. अंडर रूट ऑफ 18 is calculated as it is a anti-log of 1/2 of the log of 18, or 18 चा लॉग बघायचा त्याला डिवायडेड बाय 2 करायचं, किंवा 1/2 इंटू 18 चा लॉग बघायचा, जी व्हॅल्यू येईल त्याचा अँटी लॉग बघितला की तुमचा काय येणार आहे, त्याचा 18 चा अंडर रूट किंवा स्क्वेअर रूट येणार आहे. अँड दॅट इज 4.242 इंटू 10 raised to minus 2. आता आपला आन्सर बरोबर आले का कसं चेक करायचं, आता 10 raised to minus 4 चा अंडर रूट स्क्वेअर रूट किती आहे, 10 raised to minus 2 असतो, त्याचा हाफ. रूट 18 चं आपण काय करायचं, आसपासचा ज्याचा आपल्या अंडर रूट माहिती आहे याचा जवळचा अंक आपल्याला 16चं स्क्वेअर रूट म्हणजे वर्गमूळ आपल्याला माहिती आहे 4. हा 18 अंक 16 पेक्षा मोठा आहे, म्हणजे आपल्याला ह्याचं स्क्वेअर रूट म्हणजेच वर्गमूळ 4च्या आसपास येणार आहे, की 4 पेक्षा थोडंसं जास्त असणार आहे आणि 5 पेक्षा कमी आलं तर आपला आन्सर बरोबर आलाय. हेअर इट्स answer is 4.242 into 10 raised to minus 2. It can be written as 0.04242. Thus alpha is 0.04242. The next example is a weak monobasic acid Remember, this is important example is 12% dissociated. Here also percentage dissociation is given in 0.05 molar means C. What is percent dissociation in 0.15 molar solution? Here two concentrations are given. One percentage dissociation is given and another percent dissociation we have to calculate. But here acid is a single monobasic acid. इथं एकच ऍसिड आहे परंतु दोन कॉन्सन्ट्रेशन दिलेली आहेत. म्हणजे इथं काय करायचं आहे तर दोन कॉन्सन्ट्रेशन C1 C2 कन्सिडर करायची आणि दोन अल्फा डिग्री ऑफ डिसोसिएशन अल्फा 1 अल्फा 2 कन्सिडर करायचं. जरी कॉन्सन्ट्रेशन 2 असली डिग्री ऑफ डिसोसिएशन 2 असला तर ऍसिड सेम असल्यामुळं त्याचा Ka हा काय असला पाहिजे कॉन्स्टंट. Ka of any acid or Kb of any base is always remains constant but at constant temperature. But Ka and Kb can be changed with change in temperature. टेम्परेचर बदललं तरच Ka किंवा Kb काय होत असतो बदलत असतो. आता इथं आपला K टेम्परेचर चेंज झालं असं त्यांनी सांगितलेलं नाही. म्हणजे Ka काय असणार आहे कॉन्स्टंट असणार आहे. म्हणजे कॉन्सन्ट्रेशन आपण 2 कन्सिडर करायची आणि अल्फा पण 2 C1 C2 कॉन्सन्ट्रेशन आणि अल्फा 1 अल्फा 2. Look this solution. If alpha 1 and alpha 2 are the values of degree of dissociation at two different concentration C1 and C2 respectively, then Ka equal to formula आपला आहे K equal to alpha square C. K equal to alpha 1 square into C1 equal to alpha 2 square into C2. कारण K कॉन्स्टंटच राहणार आहे. Therefore काय आलं अल्फा 1 स्क्वेअर C1 equal to alpha 2 square C2. Then we have to put the values. Alpha 1 equal to, here percent dissociation is 12%. By percent dissociation, alpha can calculate it dividing by it to 100. Hence alpha 1 equal to 12 divided by 100. C1 equal to here given 0.05 molar. C2 given 0.15 molar. And we have to calculate alpha 2. Then alpha value of alpha 1 is 0.12. 12 divided by 100 means 0.12. Substituting of these values in the equation. हा जे इक्वेशन आहे अल्फा 1 स्क्वेअर C1 इक्वल टू अल्फा 2 स्क्वेअर C2 या इक्वेशन मध्ये ह्या व्हॅल्यूज घालू. अल्फा 1 किती आहे 0.12 त्याचा स्क्वेअर इंटू C1 0.05 इक्वल टू अल्फा 2 स्क्वेअर वी हॅव टू कॅल्क्युलेट इट इंटू C2 0.15. Therefore alpha 2 square equal to 0.12 square into 0.05 divided by 0.15. Remember one thing, in first edition of the state board textbook there is a by printing mistake there is a 12 and you have to correct here is a 0.12 and not 12. प्रिंटिंग मिस्टेक झालेली आहे फर्स्ट एडिशन मध्ये इथं 12 झालंय तिथं तुम्ही काय करून घ्यायचं 0.12. And by calculating square of this into this and divided by 0.15, this calculation is 0.0048. This value is of the alpha 2 square. अल्फा 2 स्क्वेअरची व्हॅल्यू आपल्याला जर अल्फा 2 काढायचं असेल तर याचं काय केलं पाहिजे स्क्वेअर रूट काढला पाहिजे. Therefore alpha 2 equal to square root of this 0.0048 and the square root comes here the 0.0693. Her percentage sign is not. Hence alpha 2 equal to 0.0693. If you have to calculate percentage, then multiply it by the 100. पर्सेंट काढण्यासाठी जो अल्फा 2 आलाय त्याला 100 न मल्टिप्लाय करायचं. याला जर 100 न मल्टिप्लाय केलं तर आपण काय येणार आहे 2 डेसिमल पॉइंट पुढे सरकणार आहे. म्हणजे पर्सेंट डिसोसिएशन इक्वल टू 6.93%. Thank you, students. You have to practice on these numericals examples by using the log tables. And in next lecture, we will see the next points